that parabolas can be the second form is y equals a times x minus h, the quantity squared, plus k. Okay? That's the second type or second form that parabolas can be in. The only difference is now you don't have to look for the vertex. You automatically get the vertex. The vertex is going to be hk. That is going to be the x and y coordinates of your vertex. Is going to be hk. The trade-off is you automatically get your vertex, but you will need to look for your y-intercept. Okay? Can you change from one form to the other? Absolutely yes. I would not recommend it at all. In order to do that, it's an awful lot of work. My suggestion is when they are in this form, work with them in this form. When in this form, work with them in this form. So let's take a look at one. I want to go ahead and graph y equals -3 times the quantity x minus 2 squared plus 6. Okay? So there's the problem. There's the graph. Now once again, could I change forms? Yeah, I could take x minus 2 and square it, then distribute -3, then add 6, and then it would be in this form, but there's an awful lot of room for error if you try to do that. So what I'm going to do is I'm going to work with it right in this form. In order to find the vertex, I don't have anything to do at all. It gives it to me. The vertex for this particular problem is 2, 6. And I know what you're saying. Isn't it -2, 6? No, it's 2, 6. This negative comes with the formula. If h would have been -2, if the x coordinate would have been -2, and I would have plugged it into that formula, it would have become a +2 because the negative times the negative would be positive. Okay? So no, it's going to be the opposite of whatever's in here. My vertex is 2, 6. A works exactly the same as it did before. If A is positive, your parabola opens up. If A is negative, your vertex is a maximum and it opens down. You'll notice A is negative. This vertex is a maximum and my parabola is going to open downward. The very next thing we want to do is we want to put our vertex on our graph. So I've got 2, 1, 2, 3, 4, 5, 6. 2, 6 is located right there. There is my vertex point. Now my vertex is a maximum, which means my parabola opens downward. So this graph, again, is definitely going to cross the x-axis. It's going to cross the x-axis in 2 places. How do you find the x-intercepts of any function? Let y be equal to 0. So I have 0 equals -3 times x minus 2, the quantity squared, plus 6. Again, reverting back to chapter 1.7, all the different ways you had to solve quadratic equations, factoring, quadratic formula, square root method. We're going to be using the square root method in order to solve this one. I'm going to subtract 6. I get -6 equals -3 times x minus 2, the quantity squared. In order to isolate the term being squared, I'm going to divide by -3. So I get 2 is equal to x minus 2, the quantity squared. Now I'm going to go ahead and use the square root method. I'm going to take the square root of both sides. Square root here, square root here. I get x minus 2 is equal to plus or minus the square root of 2. To get x by itself, I'm going to add 2. I have x equals 2 plus the square root of 2, and x equals 2 minus the square root of 2. Obviously, we're going to need a decimal for that. Square root of 2's got to be 1.3. Square root of 2, 1.4. Okay, so I've got 2 plus 3.4? 3.41? 3.41 for 1, and 1.41? What's it, right? If we add it, did we get 3.41 for this one?
Yes.
2 plus that? Okay, and then 2 minus that gives me 0.59. Okay. Okay. 0.59. 2 minus the square root of 2 gives me 0.59. Is that good? Everybody okay with the calculators on that? Okay. So I've got 3.410, 0.59, 0. I'll put them on my graph, and that way I'll be sure whether or not they're right or not. Well, 3.41, 1, 2, 3, and not quite halfway. And 0.59, a little bit more than halfway. Here's my vertex point. So I've got a point 1.41 units to the right. I've got 1.4 units to the left. They're right where they're supposed to be. Right where they're supposed to be. Now here's the trade-off. 6 is not your y-intercept. 6 is the y-coordinate of your vertex. So in this case, you're going to have to actually plug the 0 in order to find your y-intercept. Okay? So you have to do a little bit of work to do that. So I have y is equal to -3 times 0 minus 2, the quantity squared, plus 6. Well, -2 squared is 4. -3 times 4 is -12. -12 plus 6 is -6. So my y-intercept for this graph is going to be 0, -6. Okay, 0, -6. So I'm going down 1, 2, 3, 4, 5, 6, which gives me a point located right there. Here's my vertex point. Here's my vertex point. I have a point 1, 2 units to the left, 6 units down on the y-axis. I must have 1, 2 units to the right, and 6 units down on the y-axis. This point is here because this point is here because parabolas are symmetric about the vertex. I'm going to go ahead and connect these points. When I do, I'm going to get a graph. I'll do this a little bit better here. Bring this up through here. Nice smooth curve. Comes down through here. There you go. There's y equals -3 times x minus 2, the quantity squared, plus 6.